Albert Einstein, probably the most famous scientist the world has ever known, was introduced to the puzzling results of the Michelson-Morley experiment and became acquainted with the Fitzgerald and Lorentz contraction theory. Like his colleagues, Einstein was astounded at the results of the Michelson-Morley experiment and concluded with this statement, quote, "I have come to believe that the motion of the Earth cannot be detected by any optical experiment," unquote. The corollary of that statement, of course, is that the motion of the Earth cannot be detected for the simple fact that there is no such motion for any optical experiment to measure. But Einstein was just as prejudiced to this alternative as were his contemporaries. The unshakable foundation from which he interpreted every other piece of scientific data was that the Earth moved around the Sun. In 1905, Einstein published a paper titled On the Electrodynamics of Moving Bodies, which appeared in the German physics journal Annalen der Physik. Curiously, this was a similar title to the paper published by Heinrich Lorentz in 1895 called Attempt of a Theory of Electrical and Optical Phenomena in Moving Bodies, in which Lorentz, as we saw earlier, argued that ether pressure shortened the westward arm of Michelson's interferometer. In the paper, Einstein summed up all the experiments before him as, quote, unsuccessful attempts to discover any motion of the Earth relative to the light medium, unquote. The medium was ether, since science from Arago to Maxwell to Lorentz believed that light, since it was understood as a wave, had to travel through a medium and thus space was not empty. Consequently, Einstein set out to introduce a new electrodynamics of light so that it would fit the results of the Michelson-Morley experiment.
Although Einstein sometimes tried to conceal the fact that the Michelson-Morley experiment was a direct cause for the writing of his 1905 paper, the direct connection between Michelson's disturbing results and Einstein's invention of the theory of special relativity was admitted 2 decades later by Einstein at his speech in Kyoto, Japan in 1924.
Einstein states,
"Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect if we admit Michelson's null result as a fact. This was the first path which led me to the special theory of relativity. Since then, I've come to believe that the motion of the Earth cannot be detected by any optical experiment, though the Earth is revolving around the Sun."
Einstein said much the same 3 years earlier in 1921 at a lecture he gave at Princeton University.
"But all experiments have shown that electromagnetic and optical phenomena, relative to the Earth as the body of reference, are not influenced by the translational velocity of the Earth. The most important of these experiments are those of Michelson and Morley, which I shall assume are known. The validity of the principle of special relativity can therefore hardly be doubted."
Hence, to answer the Michelson-Morley experiment, Einstein made the assumption that since all previous experiments resulted in unsuccessful attempts to discover any motion of the Earth relative to the light medium, then logically he had only 3 choices. 1. The Earth is not moving through the light medium. 2. The Earth is moving and carrying the light medium with it. Or 3. The light medium does not exist and Earth is moving through empty space. As Einstein's biographer put it,
"The problem which now faced science was considerable, for there seemed to be only 3 alternatives. The first was that the Earth was standing still, which meant scuttling the whole Copernican theory, and was unthinkable.
As it stands, Einstein and the rest of modern society certainly wanted to avoid any suggestion of a motionless Earth as the explanation to Michelson's experiment. Yet Einstein was not satisfied with the solution offered by Fitzgerald and Lorentz. Einstein thus sought for a new approach to physics. He hypothesized that if he eliminated the ether, he could rid science of the problem of having to explain the glaring contradiction of how ether could be both a perfect fluid with no friction, but able to put pressure on matter so as to contract it. In turn, eliminating the ether would also remove the idea that space was absolute, which concept had begun with Isaac Newton and was continued by the ether-filled space of the physics in the 19th century, especially the electromagnetic equations of James Clerk Maxwell that were developed in the 1860s, which were formulated on the basis of the existence of ether. For Einstein, removing absolute space would mean that all celestial bodies are in motion with respect to one another, but not with respect to a fixed space. Consequently, there could be no center, no motionless bodies, and no ether. Everything in the universe, including space itself, would be in motion, even the Earth. After scientists had agonized over Michelson's experiment for almost a quarter century from 1881 to 1905, Einstein invented a whole new approach to physics in order to provide modern science with its only answer to this most exasperating experiment.
But eliminating the ether in order to avoid contradictions in one area only created new contradictions in other areas. Einstein still had to explain why, when the Earth is moving through an empty and etherless space around the Sun, the light beams in Michelson's interferometer are no more affected than if the Earth were not moving. What if, for example, the Earth were moving at or near the speed of the light beam? Would the light beam in Michelson's experiment be affected in some manner so that we could detect the Earth moving at such great speed?
For Einstein, the answer was no. Michelson's experiment would show no difference in the light beams even if the Earth were moving as fast as the light beam. Hence, although Einstein was enjoying the new idea that everything in the universe was in relative motion and that there was no immobile center point, he still had to account for the fact that we were not able to detect any motion at all, or tell which object was revolving and which object was not. In fact, as we will see later, by not being able to detect absolute motion, Einstein's theory could not determine if the Earth was revolving around the Sun or the Sun and stars were revolving around the Earth. But they knew as a scientific fact that one was revolving around the other. Perhaps this handicap was the reason Einstein once admitted this startling consequence to his theory. He writes,
The struggle, so violent in the early days of science, between the views of Ptolemy and Copernicus, would then be quite meaningless. Either coordinate system could be used with equal justification. The two sentences, the sun is at rest and the earth moves, or the sun moves and the earth is at rest, would simply mean two different conventions concerning two different coordinate systems.
Perhaps it is the very reason that Stephen Hawking admits the same in his 2010 book, The Grand Design.
So, which is real? The Ptolemaic or Copernican system? Although it is not uncommon for people to say that Copernicus proved Ptolemy wrong, that is not true. One can use either picture as a model of the universe, for our observations of the heavens can be explained by assuming either the earth or the sun to be at rest.
So it seems that as Einstein attempted to solve one problem, he created a larger one. If we cannot detect motion, how would Einstein know whether the Earth was revolving around the Sun or the Sun was revolving around the Earth? Since Einstein, as did everyone else before him, presumed as a dogmatic scientific fact that the Earth was revolving around the Sun, he was stuck with the ironic yet serious problem of explaining why we weren't able to detect that movement.
Consequently, Einstein was forced to provide a more plausible answer. If not, then the Earth could be considered motionless in space and the center around which the Sun revolved. The stakes were high indeed. They were the highest they had ever been for modern man. All of science for the previous 500 years had been based on the Copernican principle. That is, the presumption that the Earth was in motion and was not the center of the universe.
Even more serious was that if Einstein could not come up with a plausible answer, then Galileo would be proved wrong and the Catholic Church would be redeemed as holding the keys of knowledge. Additionally, every other science attached to a moving Earth, such as evolution, paleontology, geology, archaeology, cosmogony, philosophy, metaphysics, and many other disciplines, would need to be totally revamped. Nothing could or would ever be the same. In a word, the whole world would be turned upside down, literally and figuratively, if Einstein could not come up with a suitable answer. As noted, Einstein preferred not to use Lorentz's ether-based explanation. He writes in his book, Relativity, the Special and the General Theory, that Lorentz's hypothesis in which electrons shrink when they move is, quote, not justifiable by any electrodynamical facts, unquote. He writes,
Guided by purely formal points of view, H.A. Lorentz was the first to introduce the hypothesis that the form the electron experiences, a contraction in the direction of motion in consequence of that motion, the contracted length being proportional to the expression the square root of 1 minus v squared over c squared. This hypothesis, which is not justifiable by any electrodynamical facts, supplies us then with that particular law of motion, which has been confirmed with great precision in recent years.
Hence, although Einstein avoided Lorentz's ether-based solution to Michelson's experiment due to the fact that it was not justifiable by any electrodynamical facts, nevertheless, he was forced to maintain that Lorentz's theory that the western arm of Michelson's interferometer contracted just enough to mask the Earth's movement around the Sun. Otherwise, he would have no explanation for the difference between motion and non-motion, even if all motion was considered relative. So, according to Einstein's new theory, it was not ether pressure that caused the contraction, but some mysterious principle of nature. By employing one of his famous thought experiments, Einstein postulated that whenever things move, they contract in the direction of movement. Yet in his entire career in physics, Einstein never offered a direct scientific cause for the presumed contraction, except to say that it was a consequence of relative motion. On the same page of his book Relativity, the Special and the General Theory, Einstein writes, quote,
The theory of relativity leads to the same law of motion, without requiring any special hypothesis whatsoever as to the structure and the behavior of the electron.
Again, on the same page, Einstein claims that his particular solution, his new way of looking at the law of motion, is the definitive answer to the Michelson-Morley experiment, saying,
The second class of facts to which we've alluded has reference to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments. We have already remarked that all attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result.
As noted, although Einstein rejected Lorentz's electron flattening as the cause for the contraction, Einstein still believed that the contraction of the western arm of Michelson's interferometer, as well as the contraction of any matter put into motion, was the only answer to the Michelson-Morley experiment. He writes in his book Relativity, the Special and the General Theory,
The experiment gave a negative result, a fact very perplexing to physicists. Lorentz and Fitzgerald rescued the theory from this difficulty by assuming that the motion of the body, relative to the ether, produces a contraction of the body in the direction of the motion, the amount of the contraction being just sufficient to compensate for the difference in time. Comparison shows that also from the standpoint of the theory of relativity, this solution of the difficulty was the right one.
So, although Einstein believed that the Lorentz contraction was the correct solution to the Michelson-Morley experiment, he did not believe that Lorentz's explanation for the contraction was correct. Instead, Einstein proposed that, quote, motion with respect to the body of reference chosen, unquote, was the cause of the contraction. He writes in his book, Relativity, the Special and the General Theory.
But on the basis of the theory of relativity, the method of interpretation is incomparably more satisfactory. According to this theory, there is no such thing as a specially favored coordinate system to occasion the introduction of the ether idea, and hence there can be no ether drift, nor any experiment with which to demonstrate it. Here, the contraction of moving bodies follows from the two fundamental principles of the theory, without the introduction of particular hypotheses. And as the prime factor involved in this contraction, we find not the motion in itself, to which we cannot attach any meaning, but the motion with respect to the body of reference, chosen in the particular case in point. Thus, for a coordinate system moving with the Earth, the mirror system of Michelson and Morley is not shortened, but it is shortened for a coordinate system which is at rest relatively to the Sun.
Here Einstein coined a new word for the physics establishment, a coordinate system. But a coordinate system, according to Einstein's own words in the 1922 edition of the German physics journal Annalen der Physik, does not conform to anything real. That is, it has no substance, no physical reality, and no real definition. It was just an abstract concept made to appear as if it had a reality all its own. Most of all, Einstein's coordinate system somehow had the incredible power not only to detect objects in motion, but also shorten those objects as they moved. To his critics, Einstein's solution seemed implausible on several counts. First, how could Einstein arbitrarily decide to name space or an object as a coordinate system, since that decision made the space or object an absolute reference frame in a relative universe? Second, how could Einstein know a coordinate system moved with the Earth if he couldn't prove the Earth was moving? Third, how could he know a coordinate system is at rest relative to the Sun if he doesn't know whether the coordinate system or the Sun is moving? Fourth, how could a coordinate system or the apparatus of Michelson's experiment even know the Sun is out in space in order to be affected by it? Underneath it all, the unadmitted reason Einstein makes these claims is that he assumes, without experimental proof, the Earth revolves around the Sun. According to him and his colleagues, all scientific data must be interpreted through that unalterable and indisputable grid. Unmoved by the critics and determined to keep mankind believing the Earth revolved around the Sun, Einstein put the Earth through, for lack of a better term, his incredible shrinking machine, but with no convincing explanation of how the machine really worked. It was more magic than it was science. The Earth was put into Einstein's magician's hat, and when it was removed, it was 3 inches shorter in diameter. It was the longest, most powerful, most dogmatic 3 inches the world had ever seen. Wolfgang Pauli, a famous physicist and supporter of Einstein's theory of relativity, admitted that Einstein had no explanation for the shortening of moving matter. In his 1958 book, Theory of Relativity, Pauli writes that while, with regard to cause, Einstein distanced his theory from Lorentz's theory, with regard to effect, he kept the main ingredient, the contraction of matter, as a postulate for his special relativity theory. This led to accusations that special relativity was defying the laws of causality. Pauli writes,
It is also of great value that Einstein rendered the theory independent of any special assumptions about the constitution of matter. The contraction would not take place except for the covariance with respect to the Lorentz group of the basic equations of electron theory. We can only postulate that this is so. The epistemological basis of the theory of relativity has recently been undergoing a close examination from the side of philosophy. In this connection, the opinion has been expressed that the theory of relativity has thrown overboard the concept of causality. we take the view that relative motion is the cause of the contraction.
In order to hide the fact that the empirical evidence showed the Earth wasn't moving, Einstein had to posit that both the Earth and the interferometer contracted by the amount Lorentz calculated. No more, no less.